Hello, welcome again to Maths is Not a Mystery. We're going to be looking at a thing called growth and decay today. This is part of our percentages section. Growth and decay, we're not talking about plants and animals and things, we're talking about what happens to money or other numbers when interest or depreciation is applied. It's a percentage issue because things rise or fall by certain percent. So let's take a look at what we're talking about. Let's get into this nice and quickly. A thing called simple interest is the easiest one to work out. Now this could be a loan or it could be a savings account. You could be putting £600 into a savings account and earning 10% interest for 5 years. And the question would say, how much interest will you earn, or how much money will you have in your account by the end of it? Alternatively, you could be borrowing £600 and they're charging you 10% interest over 5 years. So the question would say, how much will they have charged you after the total length of time? The calculation is exactly the same. You need 3 elements. You need your original amount, you need your percentage, and you need what we call the term. The term is the length of time that we're talking about. When it's simple interest, it's quite easy to do. I've chosen numbers that you can do in your head, but obviously harder numbers you would be doing on a calculator. So you're going to find 10% of £600. Let's just do it written down. 10% is 10 over 100 times £600, which then becomes, of course, 0.1 times 600. And that would be £60. Okay, we know that 10% of 600 is £60. So in a year, it would have earned you £60 in interest if it was a 10% rate, or you would have paid £60 in interest if you were borrowing the money. Now, we've not used the term yet. We've used the original amount and we've used the percentage. Now we're going to use the term, and when it's simple interest, it's very simple. We get, according to its name, we get our single year and we multiply it simply by the term. Okay, 5 years. 60 times 5 is 300, and so you would be paying or earning, whichever way around it is, £300 in interest. The total cost of your loan, or the total amount of money given to you in the savings account by the end of this, would be your original 600 plus the £300 interest, which means that the total amount would be £900. So if that was a savings account, your savings account would now have £900 in it because they would have given you 300 in interest. If it was a loan, you would be paying back a total of £900. You'd be paying back your 600 that you borrowed plus your 300 interest. And that's all you do for simple interest. Original amount times the percentage, get your answer, and times it by the term. Now when we go to compound interest, it looks the same as a question, but it's not. It's harder. And this, unfortunately, is the kind of interest that usually exists in real life. What happens with it? Why is it called compound interest? Well, basically, every year your interest is added on and it changes your original amount. So in year 1, you start at £1,000 here and you add on 3%. Now, what's 3% of £1,000? 10% of £1,000 is 100. 1% of £1,000 is 10. So 3% of £1,000 is 30. So in the first year, you add £30 to your total, which means that in your account you've got £1,030. But then in year 2, you now need another 3%. And you have to find 3% of this. You have to find 3% of £1,030. So it's not finding 3% of £1,000 all the time. You're finding 3% now of £1,030, which you can't do in your head quite so easily. And then you add that on to your 1,030, and you get a new total that's a little bit bigger, and then in year 3 you find 3% of that amount. And it's called compound interest because it's compounding itself. Every year you get a new total, and you always find 3%, but you're finding 3% of a different number every time. That's going to be complicated to do in writing like this, so we need to find an easier way to do it. And of course there is an easier way to do it, because in maths we always look for shortcuts. Still using your 3 elements, this is what we do. We take our original number, and then we look at our interest rate. Now this is very important here. It's a 3% interest rate. Now just let's be logical for a second. If you're going to add 3% to this, you are going to go to a number that's larger than 1,000. If £1,000 is 100% of your original amount, which it is, then if you add 3% to it, you've now got 103%. So we're going to times it by 103%, which would be 1.03. And what do we do with that 4 years? Well, remarkably, we do this. We do it to the power of 4. So we've got our original amount as it was. We've got our percentage written as 100 and whatever that percentage is, so 1 point something. And then we've got our term written as a power. Obviously we need a calculator for that. So I'm going to put a calculator on, and we're going to do a calculation with it. So we've got £1,000, 1,000 times 1.03. Now we need it to the power 4. Now I don't know whether you're familiar with these. Over here, look, we've got x squared, we've got x cubed, and here we've got x to the power of y. That's the thing I want. It's brought us a little box up there next to the 3, so that I can put in whatever power I want, and I want the power 4. And it's given me the answer immediately without having to press the answer, the equals button. It tells me that after 4 years of doing 3% on top of whatever your new total is as you go along, I would have £1,125, and let's round that up to 51p. So £1,125, 51. Okay, and that is how you do it with compound interest. It's not as hard as it first sounds. You need to understand the principles behind it, really. That's the important thing. The principles behind it are that when you add your amount, you add your percentage, you get a new total, and then you find that same percentage of your new total, and then you get another new total, and you find that percentage of your next new total, and so on. But that's too long-winded, it's too hard to do in paper form, so we change it to do it on a calculator with a simple power. Now, depreciation is the same thing. It's the opposite way round. Depreciation is when something loses money. So when you buy a car, for example, it goes down in value, and it goes by a percentage. And there are 2 forms of depreciation that we can consider. One is called straight line depreciation, and that's the same as simple interest. And the other one is called accumulated depreciation, and that's the same as compound interest. It's exactly the same kind of thing. So let's take a look at this one. £7,000 depreciating by 10% over 3 years. Well, we're going to find 10% of 7,000. So I'm going to do 7,000 times 0.1, and of course that's going to be 700, isn't it? So it's going to depreciate by £700. We've used the amount, the original amount, we've used the percentage, 0.1 is 10%, and now we need to use the term. So £700 times 3 years, 7 3s are 21. And so it would depreciate, the car or the machine or whatever it was you bought would depreciate by £2,100. You'd lose that much money on it. To find out what it's completely worth afterwards, you simply do a subtraction sum. Okay, 7,000 minus 2,000 would be 5,000, take away another 100 would be 4,900. So the actual vehicle or equipment or whatever it was would be worth £4,900 after the 3 years. It would lose that much in value, it would be worth this. So that's the same thing as the simple interest, but it's going downwards. It's the same calculation, except here we subtract. On accumulated depreciation, it's the same idea once again. What's going to happen is that you're going to knock off 9% from your £10,000. You're going to knock 9% off in the first year, and that will change your total to a smaller number than 10,000. You'll then knock 9,000 off that new total in the second year, and you'll knock 9,000 off your next new total in the third year, and so on. So how do we do it on a calculator nice and quickly? Well, we get our original amount, 10,000. Now, we're reducing it by 9%. So what we've got to do this time is we've got to think, okay, this £10,000 was worth 100%. If we take 9% off it, then our next year's total is going to be worth 91%, isn't it? It's 100%. Take away that 9%. 91% is written as 0.91. If the value's going down, it's always going to have a 0 in front of it, because we want to multiply it by 0 point something to make the number shrink. So that 9% off of 100% takes us to 91%. And then the 5-year term tells us to do it by the power of 5. And after that, simply whack it into your calculator and see what you get as your answer. So let's take a look at it then. We're going to have 10,000 times, we said 0.91. Excuse me, that's done something weird, so I'm going to just clear it again. 10,000. Oh dear, I do apologise, I'm missing this. 10,000 times 0.91. And this time, x to the power of y, and I need a 5. And there we go. This time it tells us that at the end of all of this, our vehicle, our machine, or whatever it is worth £6,240 and 32p. 6240.32. That's actually what the thing is worth at the end of it. Okay, tells us what we're going down to. It started off at that amount, and by the end of it, it's gone down to this amount. If you want to know how much depreciation there was, it's simply 10,000, take away that, and it'll tell us how much we've lost. Okay, but the questions usually ask you how much something is worth. And that's it. That completes our work on depreciation and interest. Okay, not too difficult. Watch through again if you're not sure about it, and take a look in the Maths is Not a Mystery book. I hope that's worked for you, and good luck with your studies, and see you again soon on Maths is Not a Mystery. Bye bye.